Hinges. Lots of people don't like them, but I'm going to show you exactly how to approach and solve Hinges questions. A user opens his headquarters and hangs a sign modeled as a uniform rod. This means that the weight is at the center of the rod. The rod AB has mass 5 kg, length 4 meters, and is smoothly hinged at A. So let's label our diagram with this information. The mass is 5 kilograms, so the weight is going to be 5g, and it acts at the center of the rod because it is uniform. So I have 2 meters on either side. Now it's smoothly hinged at A. The word smoothly tells us that there's no friction, and there would be a normal reaction at the hinge. The thing about this reaction at the hinge is that it may act at an angle that we don't know. So to represent this, we'll draw its horizontal and vertical components, which I'll label H and V. If I solve for V and H and find that they're negative, then they're just in the opposite direction to my drawing, or if they're zero, there's no component in that direction. A light inextensible string is attached to the rod at C, where AC is 3 meters, and to D, which is vertically above A. So I'm going to label the length AC on my diagram as 3 meters across here, which means that this is 1 meter. The string keeps the rod in equilibrium in a horizontal position, and the angle between the rod and the string is 30 degrees. This means that the tension in the string is going towards the wall to hold it up, and I can label this angle here as 30. I can also resolve my tension vertically and horizontally, which I'll do on the side here. So I've got the tension acting 30 degrees. This is the horizontal component, and since it's adjacent is T cos 30. And the vertical component would be T sine 30 since it's opposite. Calculate the tension in the string. So for part A, now that I have my diagram labeled and we're remembering that the reaction at the hinge acts at an angle which we don't know, there are two things we could do. We could either take moments or we could resolve our forces. In this diagram, since I don't know forces at 2 points, A and C, which is the tension, I'm going to take moments. If I was just missing forces at 1 point, I could resolve. So which point do I take moments about? Well, I want to solve for T, so I don't know the forces acting at the hinge A, so I'm going to take moments about A. Since we're in equilibrium, the sum of the clockwise moments is equal to the sum of the anti-clockwise moments about the point. In my diagram, this 5g force is going to produce a clockwise moment. So I will do the force multiplied by the perpendicular distance, which is this distance from the force. That would just be 2. And that is equal to the anti-clockwise moments. Tension produces an anti-clockwise moment. So I'm going to take the perpendicular component of tension, which is T sine 30, and multiply it by the distance, which is 3. Notice T cos 30 does not produce a moment. So if I rearrange and solve for tension, I get 10 times 9.8 as G divided by 3 sine 30, which if I put into my calculator, I get 196 over 3 newtons, which is equal to 65.3 newtons to 3 significant figures. Part B. Find the magnitude and direction of the forces exerted on the rod by the wall. So this magnitude is telling us we need the scalar, and direction, we need to find some sort of angle. The forces exerted on the rod by the wall are from the hinge, the vertical and horizontal forces. So now I need to solve for V and H, and I can do that by resolving. Resolving vertically and taking my upwards direction as positive, I get V plus T sine 30, which is also going upwards, is equal to the downwards weight, which is 5g. So V is going to be equal to 5 times 9.8 minus T, which is 196 over 3, exact answer, sine 30, which gives us 49 over 3 newtons. Resolving horizontally, taking my right direction as positive, I have that H is equal to the horizontal component of tension, which is just T cos 30, which if I put into my calculator, I get 98 root 3 over 3 newtons. Now, I need to find the magnitude of the force, so I'm going to do Pythagoras. So if I just draw this out, I've got 98 root 3 over 3 newtons acting to the right, and I've got 49 over 3 newtons acting upwards. So the magnitude is going to be the square root of 49 over 3 squared plus 98 root 3 over 3 squared, which is equal to 49 root 13 over 3, which is 58.9 newtons to 3 significant figures. Now they want the direction, so I'm going to find this angle here. So to find that angle, I have opposite adjacent. So theta is equal to arc tan of 49 over 3 divided by 98 root 3 over 3, which gives us 16.1 degrees above the horizontal AB. And this is how you would solve a hinges problem. Assume it acts horizontally and vertically, and then find those components separately.